All right, first problem, we want to solve an actual differential equation using the method of Laplace transforms. Um, so what I'm going to do is I'm going to apply the Laplace operator to to both sides of the equation here. Oops. All right, so the Laplace transform of the left side is going to be equal to the Laplace transform of the right side. Okay. Now the Laplace transform of x double prime, that's going to be s squared times the Laplace transform of x, which I'll denote capital X, minus s x of 0 minus x prime of 0. Okay, that's in general how you take the Laplace transform of the second derivative of something. Okay, then you're going to have plus 4 times the Laplace transform of x, which is just capital X, and that's got to be equal to the Laplace transform of cosine of 3t, so we have a formula for the Laplace transform of cosine of kt, and so that's going to be s over s squared plus k squared, which in this case would be 9, okay, because k is 3. All right, so that's what happens when we apply the Laplace operator to both sides. Now, a couple of nice things here. We were given some initial conditions here. X of 0 and x prime of 0 were both equal to 0. So that means that both of these are 0. That's kind of nice. So the left-hand side, you can factor the capital X out, and you'd be left with s squared plus 4. That's going to be equal to s over s squared plus 9. So that means capital X would be s over s squared plus 4 times s squared plus 9. Okay. Now the trick is going to be to apply partial fractions to this to break it up into two easier pieces. Okay, so maybe let's do this off to the side. So s over s squared plus 4 times s squared plus 9, it's going to be equal to something over s squared plus 4 plus something over s squared plus 9, and since those are quadratic factors, they're going to have linear tops. Let's multiply both sides by the common denominator here. So we'd have s equals as plus b times s squared plus 9 plus cs plus d times s squared plus 4. So we'd have s equals what? As cubed plus 9as plus bs squared plus 9b plus, let's try to get the like terms together, cs cubed plus 4cs plus ds squared plus 4d. Okay, so we have matching up the coefficients on the left and right hand sides. We have we can come up with 4 equations. The fact that there's no s cubed term on the left side means that a plus c must be 0. Okay. The fact that so 9as plus 4cs on the right side, that must be equal to 1s over on the left side. That means that 9a plus 4c must be equal to 1. Okay, and then actually the other two equations involve b and d. Okay, so I mean normally this is a 4x4 system of equations, but I'm actually going to kind of separate it out into well, no, I'll just write it as a 4x4. So let's see, bs squared plus ds squared, that's got to be 0 because there's no s squared term over here. So b plus d must be 0. And then 4b or 9b plus 4d, that must be 0 because there's no constant term over here. No, so 9b plus 4d, that's got to be 0. So let's go ahead and write that system as a matrix and then RREF it to get the solution. So I'm going to have a 4 by 5 matrix. Okay, first equation is 1 0 1 0, and that's equal to 0. That's the same as a plus c equals 0. Then we'd have 9a 0b 4c 0d, that adds up to 1. Then we have 0a 1b 0c 1d, that adds up to 0. And then finally 0a 9b 0c and 4d, that adds up to 0 also. So I just take this system right here, write it as a 4 by 4 system of equations as a matrix. I then RREF that matrix. And you get that A is 0.2, B is 0, C is negative 0.2, D is 0. So, and those as fractions, that that A and C were 1/5 and negative 1/5. B and D were both 0. Okay, and yeah, so the way that this breaks up, you plug in your A, B, C, D up here, and then I'll write it down here. Okay, so really the right hand side here splits up. It's going to be 1/5. I'll write it like this. So 1/5 s over s squared plus 4 plus negative 1/5 s over s squared plus 9. And now this is, now we're to a point where we can figure out the inverse Laplace transforms of each of these pieces here. Okay, that means that the actual solution x of t is going to be, let's factor out the 1/5. Okay, and then the inverse Laplace transform of s over s squared plus 4, that's going to be cosine of 2t. Okay, because that looks like the cosine of kt where k is 2. And then similarly here, oh, and the next one, so we're going to have a minus, because when I factored out the 1/5, this term will be minus. And then this one, it'll be cosine of 3t, right? Because that looks like the cosine of kt where k is 3. So there's our solution.